Good afternoon. I'm going to scroll back up because I realized I've been talking without recording. So give me a second. I'm going to scroll back up. Just going to talk a little bit about the overview. What is the outline for today? Let's go back up. Okay. Going to the slideshow. So the topic of discussion today is about power plant. So we're going to start with an introduction. What is the energy industry? Then we're going to talk about the power plant, types of power plant, and then the power generation. How is electricity generated? So a lot of us will be very familiar with power plant. So this is just a very brief overview on the processes in a power plant. Then we're going to talk about gas detection requirement in a power plant. Okay, so and then we're going to follow up with sampling solution. So we've been talking about sampling system for a few weeks now. Really is to move away from the concept of just selling point detectors to solution selling, be able to offer a complete solution rather than supplying point detectors. And then it's the call to action. What is the next step that we hope you can help us? Okay, next slide. So for introduction, we're going to talk a little bit about the energy industry. Okay. So for the energy industry, it is basically supplying energy to everything. Industrial, manufacturing, commercial, as well as residential customer around the world. So it encompasses fossil fuel industries, electricity generation, nuclear energy, renewable energy. So it is a very big scope. Right, so it's not surprisingly that the energy industry attracts the biggest investment because you're not just supplying to the residential, you're talking about the industries as well. Okay, so if you look around, if you look at the projects, a lot of them are energy related. Okay, and the investment is ongoing because in developing countries with growing population, you will definitely have new requirement for power. Right, so the power plants are new built, but for developed countries, you will have requirement for upgrading as well as to convert fuel. Okay, so the investment in power plant is actually just ongoing. It's not a single time where you can say, okay, I have X amount of energy, I don't need to invest, I don't need to spend anymore. So then we looked at the type of power plants. We are familiar with fossil fuel power plant. Okay, some countries have nuclear power plants, and the buzzword for now, renewable energy. Okay, that includes solar, wind, geothermal, hydro, and biogas. Yeah, a couple of weeks ago, I talked about biogas from agriculture, from waste. So in addition to biogas, you have hydroelectric, that is energy from water, especially from a dam. Geothermal, energy from geothermal plant, which is basically hot water coming up from the ground in countries where they have active volcano. Okay, to generate very hot water that is enough to generate enough steam to turn a turbine. Okay, wind energy as well as solar energy. So I was looking at breakdown on fossil fuel versus renewable versus nuclear around the globe. And not surprisingly, a lot of the countries are dependent on fossil fuel as the source of power. Yeah. But some countries are doing quite well in terms of having the renewable energy generating more electricity than fossil fuel itself. In the UK, for example, last year, they actually have more electricity generated from wind farm, solar panel, biomass, and hydro, more than the what we call conventional power plants fired by coal, oil, and gas. So I think that is the direction that the industry is going. Next one. So I took this off the internet, and it's really a one-on-one guide on how electricity is generated. Okay. So in a very basic overview, fuel, in this case coal, is loaded into a furnace. Okay, the furnace is heated, it has air pumped in to burn, right? As it burns, it generates heat. The heat will boil the water in the boiler to generate steam, right? Then the steam flows to a turbine, okay, at high pressure, and it turns the turbine. As the turbine turns, the kinetic energy is converted to electricity in a generator. Okay, so when it goes through the generator, what happens to the hot water or steam? They are condensed in a heat exchanger and then cooled by the cooling tower. Okay, and then the cycle repeats itself. Okay, then from the generator, going back up. Sorry, going back to here. From the generator, you generate electricity, and then it is stepped up into a high voltage electric power to travel to houses. And then as it goes along to houses, it is being stepped down before it goes to us, the user. So that is a very brief overview of how electricity is generated. So when we talk about gas detection requirement, we very much focus on the plant itself. There are some requirements for gas detection, especially in the substation, in switchgear. So we're going to talk a little bit about that, but most of the time we're going to focus on the power plant itself. Okay, so I broke down the gas detection into types of gases, right? So we're going to talk about flammable gas, carbon monoxide and oxygen, H2, other gases like chlorine and ammonia, and then SF6. So in flammable gases, we know that fossil fuel are flammable. Okay, that's how we do. That's how it burns, and that's what we need it to do. So the first one we're going to talk about is coal. Okay, so in coal seam, you have methane, CO, and CO2 being constantly released. Okay, it's just how it is. It is formed to get with the coal, and then it will slowly seep out. So in coal-fired plants, methane is always monitored in silos and bunkers, okay, along with CO, okay. Then as the coal is being crushed before it is fed into the boiler, the transport and vaporization of coal is actually heated, okay, and it makes the coal actually combustible. So the coal dust is actually combustible by itself. That is why in recent years we have combustible dust certification. Okay, one of the reasons is to address coal dust. Okay, why? Because it is highly explosive. It becomes suspended in air. Actually, it's so fine that it can float in air. Okay, so the smallest spark from any plant equipment, okay, can ignite the dust cloud, and it causes an explosion that pulls up more dust, and it becomes a flame ball that's keep on rolling and rolling, and it becomes a chain reaction that can cause huge damage to the plant. Okay, so coal power plant now require combustible dust certification in addition to hazardous gas. Okay, so the good news is for our new product X-Cut Bright, we do have combustible dust certification. Okay. So that's in a coal-fired power plant. In a gas-fired plant, okay, methane is monitored around the LNG terminal, the storage tanks, as well as the vaporizer. So LNG is liquefied natural gas. Okay, it is liquefied so that it's easy to transport. So it is stored in its liquid form. When it is ready to be used or to be fed to the furnace or the boiler, it is vaporized so that it goes back to natural gas. So that's what the vaporizer do. So you will need a sampling point because when methane leaks, it's very high pressure and it leaks fast. So you will need detector that responds fast. Okay, so typically you will have single point gas detectors, flame detectors, as well as open path to monitor methane as well as CO and O2, right? To do that, you will have, multiple sampling point, and you need a controller to tie in all the readings together to alarm and to shut down and to initiate shutdown functions, or link to a fire suppression system. Okay, that includes manual call point, smoke and heat detectors. Okay, so in LNG plant, we will usually offer our Ermax because it's infrared time, it's fast response. You need something fast because methane is very flammable. Okay, and when it leaks, it really leaks fast. Okay, so and it's compact. Okay, and it's also because it's infrared, it doesn't require frequent calibration compared to a pedestal. So fast response and long-term stability is, the biggest advantage of Ermax. Okay, so when it needs to tie onto a controller, the GM64 allows modular configuration. So you configure by zone. So, it could be tank number 1, tank number 2, it could be by tank number. Okay, the other advantage is you can have live reading, okay, direct to a web access. So in that addition to web access, you also have Modbus outputs that ties into the DCS. Okay, so that's flammable gas. So I talked a little bit about earlier that in addition to, flammable, we also look at CO. So coal power plants generate basically CO, which is very high flammable and is toxic. Okay, so it needs to be monitored around the plant because coal dust or coal seam actually leaks CO as well. Okay, so where do we look at CO? Tunnels, bunkers, hoppers, tipper rooms. Okay, so it is a good indication of pre-fire conditions. So if CO builds up, there's chances that it's going to catch fires, soon. So what we want to do is we want to monitor CO as well as oxygen. All right, the oxygen is really to monitor to protect the personnel from low oxygen environment, especially in tight space, okay, poorly vented space. Okay. Also in chemical shed where there are, chemicals stored, it could have displaced some oxygen when the room is closed tight, and then we want to monitor it before we let the personnel going in. Okay, so in my research, I found that, well, fixed detectors is usually the way to go. That we want to have fixed detectors installed, all right? But personal detectors is recommended when entering enclosed space or when you walk around or you're working around coal piles or conveyors. So it is not a must, but it's highly recommended to have personal detectors. But fixed detection is standard. All right. So we talk about, taking readings of flammable gases, methane, we talk about CO, we talk about O2, and they are scattered around the plants. There are many sampling points. What if we can pull in the sampling to one centralized cabinet? So you don't have many sample points, okay? You don't have to maintain large number of detectors, and the sample is treated. So your sample could be hot, it could be dusty, it could be wet, or this can be treated in a sampling panel where the display, the control can be all housed in one panel, central location that's easy to maintain. Okay, so we used to have Milgut CO detection system, okay, that provides early warning of a fire within coal pulverizers and silos. Okay, it uses a sample pump to extract air samples from coal mill. So around different sample points, we have a sample pump. Okay, the sample system will have moisture or dust filters to help prolong the sensor life. Okay, and we also come with control system that allows remote monitoring. So this is just two of the panels that we have built. So this one on the right is actually a coal pulverizer where they mash up coal into fine dust before it's fed into the furnace. Okay, so I put out a little circle here. That's our sampling system. Okay, with a gas master control panel. Okay, so that's in the plant. In addition to flammable gases, CO2, there's common gas that is being monitored is actually hydrogen. Okay, so hydrogen gas is used as a cooling medium for generator. Okay, so usually they are manufactured on site, okay, to prevent seal oil system fires and scheduled shutdown. It is also used. It is also released, in a battery room. So battery backup is essential. Every single power plant will have a battery backup to keep the critical control system running. So if the plant shut down, there's no power generator, they will fall back to the battery backup. So with lead acetate battery, hydrogen gas is continuously leaked, and they are kept in an air conditioning room. So if it's not ventilated, the hydrogen gas will just keep on building up in the room, and it could get to high level. So hydrogen gas is, usually monitored inside the generator room as well as the battery room. Okay, and in a battery room, it's usually tied in with ventilation. Okay, so this is where our XCAT IQ with remote sensor works well, because hydrogen gas, as we know, is a very light gas. It will pull on top of the room. So we'll have what we call a collector cone. There's a picture in the middle here that collect light gases. Okay, the sensor will sit right in the middle. And then this, and the display can be outside the room. Okay, XCAT IQ also comes with a relay contact, okay, that can tie into a ventilation fan. So if it reaches a certain level, it will trigger a relay and it will turn on the ventilation fan before any personnel goes inside the room. So that's the advantage of XCAT IQ with remote sensor. So we've talked about flammable gases, CO, oxygen, and hydrogen. Okay, what are the other gases? Well, around the plant, you will have ammonia dosing, because in coal-fired plant, they produce a lot of nitrous oxides. Okay, so in order not to, have too much NOx in your flue gas, you have what we call anhydrous ammonia scrubber. It's a catalytic scrubber that is dosing pure ammonia, like 97 to 99% ammonia, to convert NOx into nitrogen and water. Okay, so nitrous ammonia is high concentration. Okay, so it is actually stored in tanks, but you have to monitor ammonia because when it's in high concentration, it's a flammable gas and it's very, very toxic. Okay, so ammonia monitoring is common in around storage area, transportation, okay, vaporization, and injection areas. Right, so in addition to ammonia gas, you also have chlorine gas dosing, which is very common in cooling towers. So cooling towers are big, round towers with steam coming up most of the time, and it helps to cool down the water before it's fed into the boiler again. Okay, so chlorine gas is usually commonly generated on site. Okay, and this acts as a disinfectant of the water, so that it prevents buildup of bacteria, algae, and slime. Okay, so it's monitored in the storage area as well as the dosing station. And the good news is XCAT Bright now is available to detect ammonia and chlorine gas. Okay, so that's coal, fossil fuel. I mentioned a bit about coal and LNG fire. So that's in the plant itself. Wow. So what happens if the electricity travels from high voltage or both low voltage, it goes to a transformer room. You will have what we call SF6 detection in what we call in the gas insulated switchgear or in the switchgear room. Okay, this switchgear basically convert high tension, high voltage, electricity to low voltage. It's commonly found in many industrial estates, residential. Okay, so sulfur hexafluoride is an inorganic, colorless, odorless, a very heavy gas, but it's an excellent insulating performance. Okay. Well, the special thing about SF6 is it is a very powerful greenhouse gas, so it's very bad for the environment. Okay, and the usage is absolutely monitored. Okay, and SF6 is very expensive. All right, so any leakage, it means that it's inefficient in your operation, and it's going to cost the owner a lot more. Okay, it's also regulated. So, European F-gas regulation mandate that, if you fill in X amount of F-gas, you need to record it down. You need to have, people that are trained to handle F-gas to do refilling. All right. So what's common in the switchgear room is the SF6 detector. Okay. So Crowcon offers an infrared type detector that is better than the conventional semiconductor type. Okay? Infrared, as we know, is stable. It is not affected by humidity or temperature. So it requires very little maintenance. It's something that you just install and you forget. Yeah. So it doesn't need regular calibration. Okay. But it will work and it will give a stable output. So that is our offer for switchgear room. Next one. So that's fossil fuel power plant. We also have, as I've spoken before on biogas, we also detect methane, H2S, CO, and ammonia in biogas, in waste to energy. Okay, in geothermal, we have experience supplying H2S and methane gas detectors for a geothermal plant in Indonesia. Okay. So what is the next step for us? So all of us who are, listening today, our call to action is actually to understand the local legislation in relation to the discharge. What are the gases, that the country is regulating in terms of environmental monitoring, as well as the gas leak. Okay, then identify power plants in your area. Okay, understand what type of fuel they run on. Then it helps you to approach and offer your solution. Okay, look for upgrading or re-instrumentation projects. So many coal-fired power plants are older plants. They will have upgrading projects, in terms of changing out the instrument or, doing something else different, changing out the control system, and then we can actually help to offer. Okay, so as usual, we work with EPCs for new build power plant and end users for existing plant upgrade. The other area that we could look into is actually integrator, be it a skid manufacturer, like a chemical dosing skid, a chemical supplier, somebody who supplies, let's say, for chlorine or ammonia supplier, and integrator that builds fire suppression system that would have requirement for gas detectors or control systems. So all these are avenue for us to approach and look for opportunity. So with that, I've come to the end of my presentation. Okay, please type your questions in the chat below, or you can raise your hand and and ask me any questions. Okay, for next week, our webinar is on GasPro new features. So this is exciting for us because GasPro we have new, unique gases being launched for GasPro. Okay, is there any questions? All right. Anybody have any questions at all? If not, thank you for your time. I hope to see you again next week. Bye. Stay safe. I'm gonna stop sharing.